we now learn how to rationalize denominators, and we're going to do so with some examples. Let's say we're given the following: 3 over the square root of 2. Looking at this, we can see that we have square root of 2 on the denominator, and that's a radical. In fact, square root of 2 is an irrational number, and the idea behind rationalizing the denominator is to get rid of any radical expression on the denominator. In other words, our objective is to rewrite this entire fraction, making sure there is no square root or radical expression on the denominator. And here's how we do that. This is equal to 3 over the square root of 2 times the square root of 2 over the square root of 2. And let me stop there for a second. This square root of 2 over square root of 2 is equal to 1. So when I multiply 3 over root 2 by root 2 over root 2, in essence, I'm just multiplying it by 1, and I'm not changing its value in any way. Now, if I actually multiply this 3 with this root 2, and on the denominator is root 2 and root 2, it leads to this. It will equal to 3 times square root of 2 over the square root of 2 times the square root of 2. So on the numerator, that simply becomes 3 root 2. But on the denominator, well, the square root of 2 times the square root of 2 is equal to 2. So this whole thing equals to 3 root 2 over 2. And there we go. We've just rationalized the denominator. There are no more radical expressions or square roots on this denominator. What we've just done here can be summarized as follows. As soon as we're faced with a fraction looking like a over the square root of b, then we can rationalize this by stating that it's equal to a over the square root of b times the square root of b over the square root of b. In turn, that's equal to a times the square root of b over the square root of b times the square root of b. And finally, that will equal to a times square root of b over b. And there we have it. That's the whole idea here. Let's look at another example. Let's say we're given 2 over the square root of 3. Once more, we can see that we have a square root here on the denominator. We have the square root of 3, so we need to get rid of that. And so using the trick we've just learned, we can go ahead and state that this equals to 2 over the square root of 3 times the square root of 3 over the square root of 3. In turn, that's equal to 2 times the square root of 3 over the square root of 3 times the square root of 3. And that's equal to 2 root 3 over 3. Remember, square root of 3 times square root of 3 equals to 3. And there we have it. That's the answer. Let's look at one more example. Let's say we're asked to simplify the following: the square root of 4 over 5. Well, in this case, we need to do this in 2 steps. To begin with, we point out the fact that this is equal to the square root of 4 over the square root of 5. If you're uncomfortable with that, all I've used is the following rule. The square root of a over b is equal to the square root of a over the square root of b. That's the rule I've just used there. Now, on the numerator, we see that we have square root of 4, but the square root of 4 is equal to 2. So it turns into 2 over the square root of 5. And now we go ahead and rationalize this denominator. And to do that, we use the trick we've learned. That's equal to 2 over the square root of 5 times the square root of 5 over the square root of 5. That's equal to 2 times the square root of 5 over the square root of 5 times the square root of 5. And that's equal to 2 root 5 over square root of 5 times square root of 5, which equals to 5. And we're done. And so that's how to rationalize any expression looking like a over the square root of b. And that's it for this tutorial. I really hope that helped, and if it did, please hit like on this video and even subscribe to our channel because that really does help us. I'll see you soon.